in this video we're going to look at defining what Hess's law is, explaining where and how we use Hess's law to find the enthalpy changes. Okay, so Hess's law is defined as the enthalpy change that accompanies a chemical reaction can be calculated independent of the route by which the chemical change occurs. So if I've got a reaction of reactants A going towards products B, I've got an enthalpy for that reaction. And we can see in this example that that enthalpy is going to be exothermic. Okay? But if I, instead of going directly from A to B, go via some intermediates, well, to get to that intermediate is an endothermic process. However, to get from the intermediates to the products, that is just a bigger exothermic process. So the overall enthalpy to go from A to B is exactly the same. Okay, so it's independent of the route by which it goes. And we can use this to construct Hess's cycles. So we can construct Hess's cycles using enthalpy of formation data, enthalpy of combustion data, bond enthalpy data. Okay, so frequently we're actually trying to work out what the enthalpy of a reaction is. Okay, so we can take an example where we've got SO2 and hydrogen sulfide reacting to give sulfur and water. Okay, and we don't know what the enthalpy of that reaction is. Okay, what we do know, and we can find out, is the enthalpy to convert the elements sulfur, hydrogen and oxygen to sulfur dioxide and hydrogen sulfide, and the enthalpy to convert those elements to products. Okay, so we've got the combined enthalpy of formation of the reactants and the enthalpy of formation of the products. Okay, so I want to work out what my delta HR is. Well, how do I do that? Well, I use Hess's law that states it's independent of the route taken. Okay, so I know what route 1 is worth. I can calculate that from my data booklet. I know what route 2 is worth. I can calculate that from my data booklet. Okay, I need to know what a balanced equation for the reaction for HR will be. Okay, so I know that the enthalpy of formation of sulfur dioxide is minus 297, the enthalpy of formation of hydrogen sulfide is minus 20.2, and the enthalpy of formation of water is minus 286. Okay? So, using Hess's law, we know that route 1 is the same as route 2. Okay? So, I know that therefore, I can work out that route 1 plus HR is equal to route 2. Okay? So let's say that again. Route 1 plus HR is equal to route 2. So all I do is add this number, treat this number as x, work out what route 2 is worth, okay? And therefore route 1 plus x must be equal to route 2. So therefore I can work out what x is. Okay? So route 1, that's my route 1, the delta H of formation of SO2, plus the delta H of formation of H2S, plus delta HR, that's my x, is equal to route 2, which I've written there in blue. Obviously the enthalpy of formation of an element is 0, because we're starting off with the element and ending up with an element, so that's no change. And then I've got the enthalpy of formation of water, which is 286. So delta HR is therefore equal to the enthalpy of formation from route 2 minus the enthalpy of formation from route 1, which gives me an answer of minus 234.6 kilojoules per mole. Okay, so we can look at this in a variety of contexts, and we can also use it for questions involving the enthalpy of combustion, except this time instead of starting off with my elements, my enthalpy of combustion is the energy combined to completely combust my reactants in plentiful oxygen. Okay, so my enthalpy of combustion, the arrows are going to go down this time. Okay, remember I remember this is cats eat dogs, so combustion, arrows down. Okay, cats aren't dogs, combustions, arrows down. Okay, frogs are ugly, formation, arrows up. Okay, cats aren't dogs, combustion, arrows down. Frogs are ugly, formation, arrows up. Okay, and then I can also use bond enthalpies. Okay, and again, the bond enthalpy is the energy required to convert the reactant into the gaseous atoms. Okay, and I can use this to work out what my delta H reaction is. For both of these, because the arrows are going down, I would have my delta H plus root 2 would be equal to root 1. Okay, so I'm just looking for the two arrows that point in the same direction so I can make a cycle. So for example, in the first one, if we go back, that is my cycle there. The two red arrows are pointing in the same direction. And I can't make a cycle out of delta HR and root 2 because they're pointing in opposite directions from each other. Okay? And this one, this time my delta HR and root 2 are pointing in the same direction. I can't make an arrow out of delta HC because my arrow is pointing in the opposite direction. Okay, so I can look at a couple of examples, and what I would like you to do now is to use the Zaption videos to answer the questions.